Hello, my name is Grant Von Pingle, and this is Lab 4 of the Traffic Controller Software Design. I did this project with Carolus Hermina, and I'm going to walk you through our circuit and the code we implemented and what we changed versus the original. And I'll show you a video showing everything together. So first we'll show the circuit real quick. So, so initially, the circuit included like timers, clocks, and a bunch of different stuff. And we simplified our circuit to just LEDs. This part right here, this is the only part we use, LEDs and resistors and like the Kriya board. So we like totally redid it, substituting everything for Python because we thought it would be more interesting that way, like using more of the stuff we learned in class to run this code. And there's only 5 LEDs instead of 6 because our other green one burned. So when you see it running, it'll be like this one will be green and this one will be red, meaning like this street is green to go, and then it'll like cycle through, and then this will be red and this will be green, meaning this street is good to go. We just use the same green because it got a little bit messed up, but I mean, we couldn't find any other LEDs, so that's just the best we could do right there. So it's basically the same thing. If we had another LED, we could just plug it in and plug it in for the code, and it would be exactly the same. So why don't we walk through the code real quick, and then we'll show the video and talk about it. So here's the code. I don't know if you guys can see it. Zoom in a little bit. So up here is all the different libraries we need, like GPIO, all the stuff that we use for like the Kriya board, right? And then also the widgets, because for our traffic controller, we needed a button. And so we decided to implement that with a widget, which I can show a picture of later when we show the video. And I could also show you a picture of what it looks like right now. So this is just like a button that appeared underneath the Jupyter log above the controller, or not the controller, above the console. So you just click it and it would run. So we'll explain it. So these are different libraries we need, and then this is assigning the different GPIO pins to each LED. So first one's the green one, second one's the yellow, then red, and then the second yellow and second red. This green is just the same because, yeah, like I said, we burned the other one, and so we just had to improvise with this. So let's continue. This part is getting the button widget that we're going to be using, and then also getting the output. So like we can like this displays the button right here too, and this is what we named it, crosswalk. This is the first state we're in. So this first state, the green LED is on, the other red LED is on, like the number 2, the other street, and then the rest of the LEDs are all off, which is like the initial starting state because the other traffic lights won't turn on unless you click the button, or like a car would approach, but we don't have that capabilities right now. So on button click, so when you click the button, I'll show you in the video later, it will run all these commands pretty much. And we put a bunch of waits and sleeps in between so we can talk about each different state pretty much. And then this is just the ending of the defined thing up here. And on button click, yeah, click. So we'll talk about each state. So here's the first state right here, the initial state. And then so after you click the button up to here, it will switch the green LED to, it will switch it off, and the red LED will stay on, and it will turn on the yellow LED to the left of the green LED, so the like light is turning from green to yellow. It will wait for 4 seconds on yellow like a normal light would, depending on the speed, right? The yellow light. And then after the yellow light, it would come here where it turns off the yellow light and turns off the other red light and turns on the green light and then turns on the first red light. So it'll all make sense when we show it. So instead of, like, I can go here real quick. So this light will turn, this will be green, this is red, and then this will turn off, and this will be yellow, and then this will turn off, and this will be red, and this will be green. Meaning, like, for this group, it would be green. It makes sense. It just we didn't have enough LEDs. And then this is the second state, or third state. So let's go back to the code. And we will have our countdown right now. So instead of a 7-segment display counting down how much time you have left till it switches, we just decided to like have a little console, like it would show it on there. So it would count down like 7, 6, 5, 4 every second because we put a 1-second interval or whatever. And then at the end it would say no more walking, and it would turn off the green light, turn on the yellow light. So it would turn off this light. This is still red. It would turn off this one, turn on the yellow light for 4 seconds, and then it would go from yellow, and then it would go to red, and basically it would go back, and this would turn off, and this would turn back on. So it'd be in the initial state. It would loop all the way back around through all the states, so it would go back to green, back to red. And when you click the button, it would run again. So yeah, that's our code, and these are the different like states we decided to use. We decided just to do everything on Python because we thought it'd be more interesting because this is a Python class, and we wanted to have less hardware because Python is way easier for making this thing. So let's look at the video right now. It's kind of blurry at first, but that's just because it needs to focus. So as you can see, it's gonna focus in a second. Just this is the first frame. So the green LED is on and the red LED is on. This is the first state, and it's plugged in the Korea board, which we have it on here. So we're running it, and so he clicks the crosswalk button. It switches to yellow. This is still red. It switches to yellow for 4 seconds, and then see that? It switched from yellow to red and green. So this green is along with these ones. And now it will display the timer counting down 7, 6, 5, 4. Yep. It counts down the clock. And then after the timer pops out, after the timer finishes and displays the no more walking, the green will turn off, the yellow will turn on. This red, this street is still red. But this street is yellow, about to turn red, and this red is going to turn off, and that green is going to turn on. So it goes from yellow, that red turns on, that red turns off, this turns green. So that's our whole, like, going through every single state, and instead of having a bunch of different logic gates and a counter and all of these, like, you can see it in the back actually, our counter and capacitors and different timers and the 7th segment. We just did everything digitally because it made it more simple for us, like implementing when this so this task we were told to implement Python to part of the circuit, and so we just did majority of the circuit, made the pretty much whole thing cyborg. So yeah, other than that, that's pretty much all of our code. You saw the display, it run through, cycle through when you click the button and count down. So yeah, that's pretty much it. Again, this was done by Grant von Pingle, me, and then Carolus Hermina. It's because it's a group project. But yeah, that's it. Thank you for watching. Talk to you later.